Hello everyone, welcome back. In this video, we're going to explore topic 4.7 using L'Hospital rule for determining limits of indeterminate forms. Alright, so let's take a look at two examples that we learned in chapter 1. Alright, so in order to solve this guy, we're going to factor the numerator and denominator, right? So this guy turns out to be limit when s approaches 2 of s minus 2, the bottom should be s minus 2 times s plus 2, right? Now this guy cancels out. So when s approaches 2, this guy approaches 1 over 4, right? Now the second one, you're gonna factor s squared out. So it could be limit when s approaches infinity, s squared times 1 over s squared minus 4 over s minus 5, right? Over s squared, it's going to be 3 minus 1 over s minus 4 over s squared, right? So this guy cancel out, right? When s approaches infinity, this guy approaches 0, this guy approaches 0, this guy 0, this guy 0. So the answer is negative 5 over 3, right? So this is what you learned in chapter 1, right? When you substitute 2 for s, the top becomes 0, right? The bottom becomes 0, right? Or the second one, when s approaches infinity, the top approaches negative infinity, the bottom approaches positive infinity, right? These are called indeterminate forms. There are a variety of indeterminate forms, but the most commonly seen ones are 0 over 0, infinitive over infinitive, negative infinitive over infinitive, positive infinitive over negative infinitive, or negative infinitive over negative infinitive. Or you can see something like this, right? The study of indeterminate form and L'Hospital rule is new to the AP Calculus exam for the year 2017. In AP Calculus AB, we focus primarily on forms involving 0 over 0, infinitive over infinitive, negative infinitive over infinitive, positive infinitive over negative infinitive, and negative infinitive over negative infinitive. The other indeterminate form will be discussed at length in session 7.7 during AP Calculus BC. So that over here we see that this problem and this problem can be solved using the technique you learned in chapter 1, which is you can factor them out and cancel out, right? Or you can use L'Hospital rule, right? But consider the following two limits right here. They cannot be solved using factoring or any other algebraic techniques for that matter. However, their limits do exist as indicated by the graph below, right? The L'Hospital rule theorem. If we have one of the two following cases, limit of LS over GLS when s approaches c, where both limit of LS when s approaches c equals 0 and limit of GLS when s approaches c equals 0. Or where both limit of LS when s approaches c approaches positive and negative infinitive, and limit of GLS when s approaches c approaches positive and negative infinitive for any real number c, or for c having the value of infinitive or negative infinitive. Then you're going to take the derivative on the numerator and derivative on the denominator, right? Now let's take a look at the first example. Find each of the following limits. So what you need to do is to find the limit on the numerator and denominator separately, right? So I have limit of 3s squared minus 7s plus 2 when s approaches 2, right? It's going to be 0, right? Now limit of s minus 2 when s approaches 2 equals 0, right? So it's going to be actually indeterminate form, right? So then you're going to use the hospital rule, right? So you need to say hospital rule apply. So you have limit of 3s squared minus 7s plus 2 over s minus 2 equals limit. Now you're going to take the derivative on the numerator, right? It turns out to be 6s minus 7 over 1, right? When s approaches 2. So it could be 12, so plus 7 is going to be 5, right? Now remember that, don't write 0 over 0 right here. This one is not the case, alright? So you need to write like this. Now question B, you need to do exactly the same thing, right? So I have limit of s plus 3 when s approaches negative 3. It's going to be 0, right? And limit of the denominator is going to be square root of square minus 5 minus 2 when s approaches negative 3. It's going to be square root of 9 minus 5 subtract 2 is going to be 0, right? So the hospital rule, right? So I just write hospital rule apply. So you have limit when s approaches negative 3 of s plus 3 over square root of s squared minus 5 minus 2, right? Now you're going to take the derivative on the numerator. It turns out to be 1, right? And the derivative on the denominator is going to be, and put this on the side, it's going to be s squared minus 5 raised to the 1/2, right? So it could be 1/2 times s squared minus 5 raised to the negative 1/2, right? And then times 2s, right? Because you need to use the chain rule, right? And then the derivative of negative 2 equals 0, right? So this guy turns out to be 1/2 times s squared minus 5 raised to the negative 1/2 times 2s, right? And don't forget to write limit when s approaches negative 3. S squared minus 5 raised to the negative 1/2, I bring it to the top, so it turns out to be square root of s squared minus 5, right? Over 2 and 2 cancel out, right? So it could be s. Now limit when s approaches negative 3, right? So the answer should be square root of 9 minus 5 over negative 3. So it's going to be negative 2 over 3, right? Now question C. Alright, so we have limit of s cubed plus s squared minus 8s minus 12 when s approaches negative 2 equals 0, right? And limit of s cubed plus 8s squared plus 20s plus 16 equals 0, right? When s approaches negative 2, right? So then you have the indeterminate form, right? So this guy turns out to be limit of the derivative of this one is going to be 3s squared plus 2s minus 8 over 3s squared plus 16s plus 20 when s approaches negative 2, right? You have limit of 3s squared plus 2s minus 8 when s approaches negative 2 equals 0, and limit of 3s squared plus 16s plus 20 when s approaches negative 2 still 0. Then the hospital rule applies the second time, right? So we have limit of 3s squared plus 2s minus 8 over 3s squared plus 16s plus 20 when s approaches negative 2. It's going to be limit when s approaches negative 2. Derivative of this one could be sit s plus 2 over sit s plus sit in, right? So the answer is negative 5 over 2. Alright, let's move on to question D. Now we have limit of 5s to the 4 minus 4s squared minus 1 equals 0 when s approaches 1, right? And limit of 10 minus s minus 9s squared when s approaches 1 equals 0, right? So the hospital rule applied, right? So the be limit of 5s raised to the 4 minus 4s squared minus 1 over 10 minus s minus 9s squared when s approaches 1 equals limit when s approaches 1. Now you're going to take the derivative on the numerator. It turns out to be 20s cubed minus 8s over negative 1 minus 18s, right? So you substitute 1 for s, so the answer should be negative 12 over 19. Now this is extremely important that you never write like this or like this. Neither 0 over 0 and infinitive over infinitive are numeric values and thus cannot be equated to any other expression. Alright. Now example number 2. Limit of cosine s minus 1 when s approaches 0. It's going to be cosine of 0 equals 1, right? So 1 subtract 1 equals 0. Now second one, limit s squared minus s when s approaches 0 equals 0, right? So the hospital rule apply, right? Alright, so you have limit of cosine s minus 1 over s squared minus s when s approaches 0 equals limit derivative of cosine equals negative sine, right? So it could be negative sine s over derivative of this one is going to be 2s minus 1 when s approaches 0, right? So this guy turns out to be sine of 0 equals 0, right? And this one equals negative 1, right? So it will be 0. Now question B. We have limit of natural log of s minus s plus 1 when s approaches 1. It's going to be natural log of 1 equals 0, right? And it's going to be negative 1 plus 1 is going to be 0. Now, limit of e to the s minus e times s when s approaches 1 equals e to the 1 minus e. It's going to be 0, right? So the hospital rule apply. So it's going to be, this guy turns out to be limit when s approaches 1. Derivative of this one is going to be 1 over s. Derivative of negative s will be negative 1 over derivative of e to the s will be e to the s, right? And derivative of e times s will be negative e to e, right? Now, substitute 1 for s is still 0 over 0, right? So we're going to write over here limit 1 over s minus 1 when s approaches 1 equals 0. And limit of e to the s minus e when s approaches 1 is going to be 0. Then the hospital rule applies for the second times, right? So to be, this guy becomes limit of derivative of 1 over s is going to be negative 1 over s squared over e to the s, right? When s approaches 1, remember derivative of 1 equals 0, derivative of e equals 0, right? So when s approaches 1, this guy approaches negative 1, right? This guy approaches e, so this one is the final answer. Now let's move on to question C. Remember, this one is one of the two questions we saw at the beginning, right? We use the technique we learned in chapter 1 to solve this one, right? And the answer is negative 5 over 3, right? Now we're going to use last Pythagorean rule to solve this one, right? So we have limit of 1 minus 4s minus 5s squared when s approaches infinity. It's going to be negative infinity, right? And limit of 3s squared minus s minus 4 when s approaches infinity is going to be infinity, right? Now keep in mind, don't use the equal sign right here, alright? So the last Pythagorean rule applies, right? So we have limit when s approaches infinity of this one, right? So I'm gonna take the derivative of this one. It's gonna be negative 4 minus 10s over 6s minus 1, right? Now I'm gonna do exactly the same thing, right? So limit of negative 4 minus 10s when s approaches infinity is gonna be negative infinity, and limit of 6s minus 1 when s approaches infinity is going to be infinity, right? So this one is the indeterminate form. So we're going to apply the last Pythagorean rule one more time, right? So the last Pythagorean rule applies. It's going to be right here, limit when s approaches infinity. Derivative of this one is equal to negative 10. Derivative of this one is equal to 6. So it's going to be negative 5 over 3, right? Now, question D. We have limit of 4s squared minus 5s plus 2 when s approaches infinity is going to be infinity, and limit of e to the 5s plus natural log of s when s approaches infinity is going to be infinity, right? So we have indeterminate form, right? Then the last rule applies, right? So this guy becomes limit when s approaches infinity of 8s minus 5, right? Derivative of this one, and the bottom right here, derivative of e to the 5s is going to be 5 times e to the 5s plus 1 over s, right? Remember this one right here, we need to use the chain rule, right? E to the u prime is going to be u prime times e to the u, right? Now we're going to check this one to see if this one has indeterminate form one more time, right? So we have limit of 8s minus 5 when s approaches infinity is infinity, right? And limit of 5 times e to the 5s plus 1 over s when s approaches infinity is going to be another infinity, right? So last Pythagorean rule applies one more time, right? So last Pythagorean rule applies. So we have limit when s approaches infinity of derivative of this guy turns out to be 8. Derivative of this guy turns out to be 25 e to the 5s minus 1 over s squared, right? Now when s approaches infinity, the top approaches 8. The bottom approaches infinity, right? So the answer is 0. Now let's take a look at example number 3. Find each of the following limits. The graph of average is shown below. We need to find the limit of average over s squared minus 9 when s approaches 3, right? So we're going to check the numerator and denominator, right? So we have limit of average when s approaches 3. So s approaches 3 is going to be 0, right? And limit of s squared minus 9 when s approaches 3 is going to be 9, subtract 9 is going to be 0. We need to say the last Pythagorean rule applies, right? So we have limit when s approaches 3 of this guy right here, right? So take the derivative of this one, it could be f prime of s, and this guy turns out to be 2s, right? Now, limit of f prime of s when s approaches 3 is going to be the slope of this line, right? So we need to find the slope of this guy using the rise over run, right? So it could be like this. So I'm going to go up by 2, go to the left by 1, it's going to be -2, right? And when s approaches 3, this guy approaches 6, right? So it could be -1/3. Now let's move on to question B. The function f of s and g of s are differentiable for all s using the following table to help find the limit, right? Now find the limit of this guy, right? Now I need to check the numerator and denominator. So I have limit of f of s minus 4 when s approaches 2 equals limit of s when s approaches 2 is going to be 4 right here, right? So 4 minus 4 equals 0, right? Second, limit of g of s times s squared when s approaches 2 is going to be g of s when s approaches 2 equals 0, right? 0 times 4 equals 0, right? So the L'Hospital rule applies. So this guy becomes limit derivative on the numerator is going to be f prime of s. Derivative on the denominator, we need to use the product rule, right? So we have g prime of s times s squared plus 2s times g of s, right? When s approaches 2. So we're gonna find the limit of this one when s approaches 2. So it's gonna be f prime of 2 is gonna be -2, right? Over g prime of 2 is going to be 3 times 2 squared plus 2 times 2 times g of 2 equals 0. So the answer is -2 over 12. So it could be -1 over 6. Now let's move on to the last one. Example number 4. This question comes from the 2018 AB Calculus exam, AB. Question 5. Let f be a function divided by f of s equal e to the s cosine s. Let g be a differentiable function such that g of pi over 2 equals 0. The graph of g prime, the derivative of g is shown below right here. Find the value of limit of f of s over g of s when s approaches pi over 2, or say that it does not exist. Justify your answer, right? So basically, you need to check the numerator and denominator, right? Limit of f of s when s approaches pi over 2 is going to be limit of e to the s cosine s, right here. When s approaches pi over 2, right? Cosine pi over 2 equals 0, so this guy actually 0, right? Now limit of g of s when s approaches pi over 2, actually 0 is given there, right? Right here. So we have indeterminate form, right? So the L'Hospital rule apply, right? So it's going to be limit when s approaches pi over 2 of this guy, right? So it could be f prime of s over g prime of s, right? We're going to use the product rule, right? U times v prime is going to be u prime v plus v prime u, right? So this guy turns out to be limit when s approaches pi over 2 e to the s times cosine s minus sine s times e to the s, right? Over g prime of s, right? We substitute pi over 2 for s, right? So this guy turns out to be e to the pi over 2 cosine pi over 2 minus sine pi over 2 times e to the pi over 2 over chi prime of pi over 2, right? So this guy equals 0, right? This guy equals negative pi over 2 because sine pi over 2 equals 1, right? Over chi prime of pi over 2 actually 2/8, right? So the answer is negative 1/2 e to the pi over 2, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.